All right, it's 10:59. Thanks everybody for joining in. We'll let everybody trickle in for the next couple minutes. Again, this is our monthly webinar. Today we're going to be talking about our approach to minimizing downtime. I'll let everybody join in, let everyone grab their lunches, and we'll start this in about a minute or so. All right, before I start this, you do get a continuing education credit for this. So if you wouldn't mind, just throw your email into the chat and we can use that to send you your continuing education credit for this webinar. I'm going to go ahead and start this off. So we work with a lot of petrochemical refineries, industrials, and plants, and we know that downtime is, the culprit of a lot of budgets going lost. So this is going to be our approach to minimizing downtime. We're going to talk about our emergency response, in particular our leak sealing, corrosion repair, and rebuild products, and how we learned from all of that to create what we call the planned reaction program. And we think it could be a huge benefit, and it has been a huge benefit to a lot of our clients. So starting out with emergency response, this is what we're known for, coming out at the blink of an eye and making stuff happen. One of the main things we're going to use with our emergency response is going to be our engineered composites. These are carbon fiber, epoxy, composite materials that can be used to basically create new wall for damaged assets. So these are ASME engineered composites. They are approved repairs for API 570, 653, and 510, so we can use them on tanks, pressure vessels, and piping. And what they do is they come with an engineered package and give you a reliability for the repair. So you know that this can hold a certain amount of pressure, this can last a certain amount of time, and this is compatible or fit for service with your service that you have that you're dealing with. So we use it a lot. You'll see the examples. We sometimes have to use other products in conjunction due to the emergency of the repair. So I'll just kick it off and start it with one. So this is a amine holding tank. This is one where if they were to empty this tank out and you know do that whole process, it would lead to a huge shutdown of part of their process plant. So they were doing some routine maintenance on this, took off the insulation and saw they had several locations with severe external localized corrosion. So we came up with a repair plan, an ASME engineered system, and we had in the back of our minds that some of this corrosion might be through wall once you touch it or try to prep it. And the first day we did come up with a leak and we were able to install what we call a vent plate. So if you're looking at this right here, you might look at this and say, I don't know what's going on. This is just a day in the life for Belzona. So what we had a vent plate that we had on site at the time because we knew this could have been a possibility. So this is just a plate that's curved to the curvature of whatever asset you're dealing with, and it has a nipple or an orifice that allows the leak to go through. So we bonded the plate down with our quick curing surface tolerant products and held them in place using our magnets. And as you can see, the leak is coming out of the nozzle of the plate. So we're basically shielding our product from the chemical during the cure time. So this product takes about 3-4 hours to cure. So we would allow it to cure, come back, reinforce it. So we came back and reinforced it, allowed that product to cure, and then capped it. At this point, you cap it, you wait about 30 minutes, make sure it's not leaking anywhere, and then we can go ahead and put on our ASME engineered system. So within our package for this tank, we had this procedure ready. We knew that this could have been something that would happen, especially with the extent of corrosion that was on the tank. There was several other spots around the tank we didn't have to deal with any other leaks besides this one, and we were able to repair all the critical areas for this tank without having to empty it out or shut down the process. So definitely a huge minimization of downtime and pretty much no downtime. And this is some of the other spots. So another one right here, we had a cracked flange on a pump. This was during a turnaround, um, and they had an issue here, so this was not in service. And but they needed something quick, without having to do extensive overhaul of equipment or put in a new pump, do any major hot work or anything like that. So they needed, we needed to understand why this happened. What can we do? So we went through the process, gave them the package, and we were able to come really quick and install something, and just decrease the amount of time they were going to have to spend during the turnaround, getting a new pump, doing different things. So this was definitely, and as you can see, we're using that ASME engineered system that we like to use. But as you can see as well, um, this flange went from a flange geometry to a little bit more bulky. So depending on what we're repairing, we might have to use some of our other products to shape or mold, for instance, a flange to make it wrappable. So so this has some other Belzona products underneath it that make it a more wrappable um, geometry. So this is a tough one. Definitely want to have your installer trained to do something like this. Uh, it's not, the hardest thing to do, but there are some geometries that are trickier than others. So this was one of the installations that we did that really saved our client having to do extensive engineering or ordering of equipment and extensive downtime. Going with another tank here, this is a tank that had a hole in it, and they were actually just operating the tank at a lower level. They could not shut down this tank or empty it out without having to shut down a major portion of the plant. So that your standard repair of this maybe 30 years ago was drain the tank and weld a patch over the hole, which can be done, but obviously results in downtime. So what we were able to do was they were able to keep the tank level low, and we were able to install a quick curing product over the hole, and then do a better surface preparation and install a uh, cold plate bond. That's where we bond a plate over a defective area. And here we use the product that is compatible with 98% sulfuric acid. And then on top of that, we went with our ASME engineered system. Now, once that first solution that was just kind of put over the hole cures, they're able to raise the level of the tank and put this back into service or back into maximum capacity. So this is an option for a lot of different tanks. We do this quite a bit where there's a localized pinhole on a tank and they're able to drop the level for us. We come in and patch it. Once it's cured, they raise the tank level. As you saw in the first example, we can also deal with leaks at times, but we can do it either way. So it just depends on the chemical, the risk assessment, what we can do. And, we'll go, and that can be a fairly quick process figuring out what we can do in our. So as you can see, we do like to use that ASME engineered system. It is a very reliable system. It works. It comes with a calculation package. But as you also saw, there's a lot of other products that go with it, especially when you're dealing with live leaks, chemicals. You're going to need more products than just that ASME engineered system. So with Belzona, we're lucky that we have an on-suite of products, chemical resistant products, quick cure products, surface tolerant products. As you can see here, you have a leak coming out of a pipe, and you can't just throw anything over this. You need a specific product that can be used to plug this live, cure while it's wet, cure very fast. So we do have an epoxy plug type product that can be used to seal a live leak like this. Once you have the seal, then it becomes a little bit easier, but you still want some other types of products. So here we were able to put some quick cure patches over some of the other leaks that they found, and that allowed us to do a good abrasive blast of everything else. And then we went ahead and went with our ASME engineered wrap once we had all the leaks settled and everything ready to go. At times, though, we might not need the ASME engineered wrap. So, for instance, for leak repair on floating roofs, a lot of the times we're using those quick cure, surface tolerant, oil tolerant products to seal leaks. And then we go over the top of that with a flexible grade Belzona product with the reinforcement mesh. So here we were dealing with multiple leaks and multiple corrosion areas. Once again, if they were to do weld repairs or shut down this tank, you're talking millions of dollars, you're talking millions of dollars of loss and downtime. So we were able to do this while the tank was in normal operation. Some of the repairs you see here were for leaks. Some of them were corrosion areas that we coated so that we wouldn't have a leak in the future. So the general procedure for this is stop leak. Once leak is stopped, perform some sort of surface preparation that's allowable for the acid. Depending on the chemical and the scenario, it's going to be a different surface preparation. And then we make a larger repair that's going to be have a little bit more life to it than just plugging it with a little plug. So you definitely want to plug it first, get the leak stopped. A lot of people stop there, but we'll usually take it the next step, do a better prep, get a bigger repair, make it last a little longer. So this is a tank that we, as you can see, several spots received our repairs. Another scenario that comes up quite a bit, it's not always an emergency, but sometimes it is just flange face and sealing areas. Could be sealing areas on channel heads of heat exchangers, anything, manways. And sometimes they do lose their seal due to corrosion. Or when you open it up during the turnaround, you might see more corrosion than you thought. And we do have a great solution for this, and we do it quite a bit, where we can rebuild sealing areas with our non-metallic rebuild products. And what that does is it gives you a fast return to service. You don't need to use any hot work or welding. And it also creates a non-metallic seal surface, so you're not going to have any crevice corrosion, galvanic corrosion, whatever corrosion you're going to get in that seal area. So just some quick examples. So this was a gasket sealing area on a manway. As you can see, it was pitted due to that crevice corrosion. So we were able to come in one day, build this up, and create a new non-metallic flange face. And we do have kits where you can build the gramophone finish if required. So this is definitely something that's used. It can be an emergency, or it could be to reduce time during a turnaround, or to increase the efficiency or reliability of your seal area. We also do this for pumps. A lot of pumps in the stuffing box area. We can rebuild those, and it gets a lot of times we'll rebuild it, and the product can actually get machined later. So we're just increasing that reliability of that stuffing box area so that it doesn't corrode over time and your clearances stay intact. So just things that can stop an emergency from happening or fix an emergency that's already happening. So all this led to the planned reaction program, which is pretty much we're working with the client over time. We're fixing their problems. We're coming out at the blink of an eye to fix a leak. So we finally get with them, and we've made enough relationships where we could talk and we look at, hey, so what's going on? What's causing all these issues? What are some possible downtime scenarios that you're having? Can they be prevented with a process adjustment? That's obviously going to be one of the first things you try to do. Can we change up the process to not have this issue? If you can, that's great. Or maybe we can install a corrosion prevention system. Maybe something as simple as coating the pump is going to create less corrosion over time, or coating the pipe is not going to let it corrode, externally. So we'll look at that. Obviously, with that, we have to understand the corrosion mechanism. The corrosion is most of the time going to be the issue of the downtime. So once we understand everything, we design a flow chart, create procedures, and designate the required stock that you're going to need. So looking into before planned reaction. So this is one of our clients. Before we started working with them regularly, they had one scenario where there was a leak on the piping, created a shut-in. This was offshore. So they have a shut-in. They don't have a plan in place to fix it. They're waiting for a solution. They're waiting for product to come. They're waiting for the pipe to come to replace the pipe. This created millions in losses due to extended downtime, about a week or so, that they could not start the process. Now, once we've created our problem, first off, they're getting a lot better with inspection, so they might find the corrosion before it leaks through. Either way, leak or thin wall corrosion, same day design and approval, stock on board, personnel trained on site, same day repair execution, start process, within a day or so of finding the corrosion. And this is actually an example of that, a picture of that client, the one we work with. So this is typical what they find out there. This is part of our design scope, and this is the executed repair. So this was a major oil and gas offshore company, just caught off guard by corrosion creating a leak, which they didn't have the plans in place to repair it as fast as possible, which led to an extended shut-in, which led to obviously a lot of issues as far as downtime and cost. So now that we have this system in place, each one of their sites has stock ready. They know what we need as far as to give them the design same day. They work with the regulatory agencies, so we know what they need, they know what we need. So it's a very fast approval and execution process. Looking at it in another way, everybody's going to need shutdowns. We understand that. Um, and that creates downtime. So we have to do our inspections of our vessels and equipment. However, what we've seen is, if you're not taking care of the equipment, once you do your inspection, if you don't put the right coating in there, you're going to have failed coating. If you don't have it coated to begin with, you have a lot more corrosion discovery. What does that result in? Extended time addressing the discoveries, extended time trying to find solutions, which creates a turnaround that maybe went a little longer than we wanted to. So what we've worked with one of our clients is we use our fit for service proven coatings. We coat the equipment during the turnarounds with a strict QA QC process. And once we use a coating that we know is fit for service, we install it to the right spec. Now, instead of it being a 5-year interval for inspection, it's maybe a 7 or 8 year. So we don't have to do as many inspections within a 20-year period. Also, when we do inspect it, there might be some clients where they have to do an inspection every 5 years. You can't get by that. However, when we do inspect it, there's less discovery. So there might be a touch up here or two, but there's less repair work, which creates a quicker and more efficient turnaround. So this is definitely something that, this is the client that I'm talking about. So before, this is the kind of damage they were seeing after 5 years. So which created well, we can't just put this back into service. Now we have to, we thought this was coated. We had anodes, we had a coating. Now we got to figure out what we want to do because we don't want to lose any more metal that create more issues for the next turnaround. So now we're coating these with a much more resilient system. And when they come back in 5 years, it's minimal. There might be a touch up here too, but it's boom, boom. And finally, a life extension project. This is one which was a tank that was past its design life. And really, if it kept this going, it was going to have issues. It already had a leak on the manway, which caused the shutdown. So what we ended up doing was during the inspection, they figured, we can coat this and keep this in service for another 10 years. And we addressed some of the major concerns. Some of the nozzles were severely thinned. So we did nozzle inserts. We also reinforced the manway and other nozzles with our ASME engineered composite. So really just bulletproof this tank for the next 10 years so that we wouldn't have any issues down the line. So life extension, minimizing downtime in the future as well. So thanks for your time. Thanks everybody for joining in. Any questions?